facing, turning, and shouldering on the metal lathe. We'll be using an old South Bend 9-inch tabletop that dates from the 30s or 40s for this demonstration. We'll be cutting with a right-handed tool bit, and because some shops may have one or the other, we'll demonstrate using both a quick change tool post as well as a lantern type tool post. The right-handed bit we'll be using today is a brazed carbide, but understand a high-speed steel bit will do just fine. Now make Lathe Safety a non-negotiable item in your repair shop. Hand spin the chuck before starting the machine. Never extend stock out of the chuck more than 3 times the diameter without live center support. Ensure that your speeds are appropriate. Always wear safety glasses and appropriate shoes. No loose clothing, jewelry, or long sleeves. And of course, tie long hair back. No neckties, etc. Now our goal is to use a right-handed bit set in a single unchanging position for all 3 operations: facing, turning, and shouldering. Hand spin the chuck before starting the machine. Now using the carriage and the cross slide, introduce the tool bit to the workpiece. We're going to start cutting in just in front of center, and we'll cut in about 10 or 15 thousandths. With the cross slide now, proceed to center, and then immediately draw the tool bit back to the exterior of the workpiece. The advantage of facing this way is you get a smooth, clean, uniform finish, and you preserve your tool bits. Here's a shot of the quick change post setup. Now here's the same operation, just from the operator's perspective. Again with the cross slide, proceed to center, and then draw the cross slide back out to the exterior of the part. Now when we talk about appropriate speeds for turning, general formulas that work well are, for soft metals, 300 divided by the diameter of the part. For plastics, 400 divided by the diameter of the part will give you a pretty good ballpark in terms of how fast to be spinning. For example, the 1/2-inch diameter brass rod we just faced would be turned at 600 RPM. 300 divided by 1/2 inch is 600. Now back to facing. The same operation with a lantern type tool post and a left-handed tool bit holder combination. Here's our setup. And just to emphasize, which is the left-handed holder. Now notice that the facing operation itself is exactly the same. And here's the same thing from the operator's perspective. Now when you face, always ensure that the carriage is held steady. Your first option is to hold the carriage steady with your left hand as you face. In this clip you can see the left hand on the carriage hand wheel. The reason for holding the carriage steady is, especially when you're machining harder parts, the force of the operation is going to want to push that carriage away. especially when you're machining things like cold rolled and drill rod. And so holding the carriage fast with your hand is one option. Now if your lathe has a carriage lock and it's still working, you can engage the carriage lock. The advantage of using the carriage lock is, of course, it's a sure thing, but also it frees up both hands to manipulate the cross slide. And you'll see in this clip that that's exactly what we're doing, and it's going to ensure a more uniform finish on that part that we're facing. Now, facing and turning and shouldering is dependent upon how that right-handed tool bit is set up in your lathe. We're looking for height. The height needs to be exactly centered to the chuck. And we're also looking for clearance on the left and front side. For setting the height, you can chuck your live center in the chuck of the lathe. Always make certain if you do that you're chucking the cylindrical body. Here's another shot. And still another from a different perspective. And again, what we're doing is we're just setting the height of the tool bit proper. Now, another option is just to turn a tapered point on a piece of stock. That way you're not opening the chuck jaws to get your live center in there all the time. Once your height is set, the actual angle of the tool bit is what you're looking for. Draw an imaginary X, and that's what you should see. Clearance on the left side and on the front. Now once the part is faced, we're going to turn it to a specific diameter. Now some things to know. Most lathes can turn diameter accurately to 1/1000th of an inch. The cross slide can be advanced in 1/1000th of an inch increments using the cross slide micrometer scale. The first step in using that is to coordinate the tool bit location with the cross slide micrometer scale. Now the way we start is we touch off on the workpiece. With it spinning, introduce the tool bit very slowly until the point where it just very lightly scratches or scuffs the surface of the workpiece. Now, holding the cross slide, the micrometer scale will move independently. In this instance, we're setting it to 0. So now, if I want to remove 0.10000ths of an inch, I can. Whenever you turn, limit material removal to 50,000ths maximum with each pass. Now we'll show turning more in a minute. Now from the beginning, our goal is going to be to face. We're going to turn a piece of stock from 625,000ths to 525. We're going to remove 100,000ths, and we're going to shoulder what we machined. Now here we go with facing. Hand spin that chuck. Remember that carriage needs to be held fast. Either hold on to it with your left hand or engage your carriage lock. Once the part is faced, we can think about turning to diameter. Hand spin the chuck, and now we're going to touch off. Again, introducing the tool bit very slowly, and all we want is for that part to be scratched. Holding on to the cross slide, we set our micrometer scale to 0, and now we can advance that cross slide In this instance, our goal is to remove 50 thousandths. A good practice to get into is to do test cuts. And what we're doing is we're machining in about 1/8 to 3/16 of an inch. Just enough to get a micrometer or a caliper in there to take a measurement. In this instance, the micrometer told me that my pass was not 50 thousandths, it was actually 42. So I'm 8 thousandths shy of that 50 thousandths goal that I wanted for my first pass. Now right now, it's not a big deal, because on my finished pass, I'm just going to make that 8 thousandths. Now the reason I'm off by about 8 thousandths is, if you noticed when we touched off, and you can review the video, but if you noticed when we touched off, the part wasn't very round. Well, it was probably 8 thousandths out of round. Since our goal is to remove 100 thousandths of an inch, I'm going to advance the tool bit another 50 thousandths. Again, a test pass. The advantage of a test pass is I still have enough stock sticking out of that chuck so that if I'm undersized, I can face off that which I don't want and continue making whatever I want to make without having to remove the stock out of the chuck, etc. And what the micrometer is telling me, that indeed I did cut 50 thousandths. So I'm going to finish this pass. Now at the end of this pass, notice that we're going to clear the tool bit to the right using the carriage. We're not going to back the tool bit off of with the cross slide. We don't need to. So clear to the right and you're in good shape to proceed. Now, see that shard hanging there on that tool bit? Never grab a shard with your fingers. Always use a brush or a pair of pliers to remove shards like that. Second pass, 50 thousandths removed. Now our final pass is going to be 8 thousandths of an inch. With your final pass, with your finishing pass, you want to remove between 5 and 15 thousandths of an inch. On older lathes, where the cross slides are a bit loose, if you get under 5, sometimes it floats and you get a poor finish. When you get beyond 15 thousandths, the finish tends to be a little bit rougher because we're still kind of getting the hogging of the part. Again, a test pass. The micrometer says I'm good to go, and now I'm going to finish. You'll actually see the finish on this piece improve. And again, so make your finishing passes between 5 and 15 thousandths, and you'll produce really nice clean work. Some machinists will add oil to their cutting. Some will actually use shortening on their finishing passes. For the most part though, with what we do, dry cutting is just fine. Now, we faced and we've turned the part down 100 thousandths of an inch. The last step is to shoulder. The clip opens on moving the carriage on that finishing pass. Once we reach the base of the part, we're going to hang on to that carriage. so that it doesn't move. We're then going to use the cross slide, and we're going to draw the cross slide back toward us. And because the cross slide and the carriage work on the XY axis, that's going to create that square shoulder at the base. If we don't do it, the base of that part is going to assume the angle that the tool bit is set at. So here's one more time, I think just a little bit slower. Hold, and now you'll see the tool bit draw back. And that's shouldering that part. Now that's the fundamentals of facing, turning, and shouldering, using the micrometer scale on the cross slide to advance. Now we want to show you one more thing, and it's a special situation. If the workpiece that you're working with has an uneven end, you might want to square it up a little bit. So here's what we're talking about. You can see how uneven that is. Now, especially with carbide bits, what will happen if we try to face with the techniques that we're showing here, most likely that carbide bit is going to get chipped, because carbide bits don't handle intermittent hits from parts like that. So take it to your sander and square up that end. Once it's squared up, you can proceed to face as normal. And that's the end of the video. Thank you very much.